The last time we had said that you last time we had said that you, if you had a inductor, then that inductor would be SL. Well, people like Freighter will tell you that we can also replace S by J omega. So we can
Sure.
write,
Can you record it?
yeah, I was asking what are you, well, all right, let me press record on this. I'm not
Same
using,
person when normally record.
all right, through the computer crash, we don't really know my way around this tablet here to go, as up to now, we can't find record.
Someone else is recording the session, sir.
Huh?
Someone else is recording the session, sir.
Okay, all right, thanks. All right, so we were saying that you can replace S by J omega, and there's a reason why I want to replace S by J omega. We want to replace S by J omega, so instead of writing 3S, we're going to write 3J omega. So this is J omega and S, and here, instead of writing 1 upon SC, which is 1 upon 2S, we're going to write, instead of S, if we want to look at the frequency response, then we can write J omega C. And this, in this case here, our J omega C is 1 upon C is 2, so it's going to be 2 J omega C. And this is 3. Now, all right, so
Sir, you then take out the C for the capacitor, because the capacitor is 2
right, so yeah, you take out the C. So now, let us go a little further. What we are going to do, well, we do it a little later. Or let me do it now. What we are going to do is multiply the numerator and the denominator of this by J. So this is going to be equal to J. And if I multiply J by J, what am I going to get? J squared. And what is J squared equal to?
-1.
-1. So I'm
Minus
just going to
1.
put, right, so this is going to be -1 upon 2 omega. Did something silly. Let me go back to the problem. I'll make life easier. So this is 10 volts. And I'm going to make omega equal 1 to make life simple in the first case. So this is 10. It's an AC source. 10 volts. Omega equal 1. All right. So now, if we have that, and we are using mesh analysis here, what is the equation for I1? The loop that I1 is in, sorry. So I'm going to call the loop that I1 is in loop 1. So what would the equation be that I would write out for loop 1?
what, 10 volt equal
10 volts equal
equal 2I1
2 I1
I1 plus 3J omega
3 J
J omega
omega. So that is the,
oh yeah.
what's the current? So that is, let's call up for resistance. What's the current? Is I1 and I2 going through there? What is the current through this
I1
three
minus
delta?
I2.
Look at how we have them. Go again.
Oh, it's I1 plus I2. I1 plus I2.
Right, because the two of them are aiding each other.
Same
Two of them in the
direction.
same direction.
Yeah, I1 plus I2.
All right, and we can simplify that to 10 is equal to 2 plus 3J. Omega is 1. I1 plus 3 omega is 1. So this is going to be 3J I2. So that's equation 1. All right, everybody with me so far?
Yes, sir.
Yes, sir. I'll just
All right.
write off this up.
So while we're at it, you can just write down for oh, sorry about this. This is J. So multiplying top and bottom by J. So this is going to be J over omega. All right. So what would be the for I2? For the loop 2, what would be the equation that you would write?
Would it be 0 equal
0 equal I'm going to attempt to turn this again. Hopefully it works this time. Nope.
Simple expression for the second mesh.
Ah, boy. All right. So Today is not my day at all. All right, so we're going to write 10, that's the first equation, 2 plus 3j I1 plus 3j I2. And the second equation is 0 is equal to,
Break up wicked again.
what is the second equation now?
So 0
There's no source, so we write 0.
0 equal 1 over j omega, 1 over 2j omega.
Minus 1 over 4
2j
omega
I2
I2 plus
3j omega
3j omega
I2 plus I1.
I2 plus I1. I'm
3 plus 3 I2.
Start with I2. 3 I2. Right? 3 I2, J omega, and this for the inductor. So capacitor, inductor, resistor. Omega is equal to 1. So this is going to be minus a half J I2 plus 3J I2 plus 3J I1 plus 3I2. I'll put everything together. Then what we are going to get is that is just going to be 3J I1 plus I2, 3I2
What about includes it makes the industry is so
right, so this is going to be 3
is that so come on the middle
plus these two 3J I2 minus a half I2. So this is going to be plus 3 minus a half is going to be 6 upon 2 minus 1 upon 2. So that's going to be 5 upon 2 J I2. So that's our equation 2. So let's write this in matrix form. First equation is going to be 2 plus 3J. Second equation is 3J. And in this second equation, this is 3J. And this is 3 plus 5 upon 2J. I1, I2 is equal to 10 upon 0.
Different businesses within the accounting sector funding customers operate their scale.
All right. So now, how do we find I1 and I2?
Happening, this is happening. This is happening.
I1 and I2 is the inverse of this matrix here, multiplied by 10. The column vector 10, 0. So this is going to be 2 plus 3J, 3J, 3 plus 5 upon 2J, inverse of this times 10, 0.
See bracket and need to make a number of decisions.
Equal to. Who have the MATLAB? So who have the MATLAB? Of course, I was speaking to myself. All right. Is the
MATLAB man there, so that
Huh?
the person the MATLAB will direct there.
Okay. Here's the bar computer. So I use the MATLAB on this. So I'm going to go onto MATLAB and I'm going to enter the following. Now, when the two arrows, square bracket, 2 plus 3j, 3i, MATLAB doesn't recognize j, 3 times I, semicolon, 3 times I, 3 plus 5 to slash 2. So I don't need to put in this. All right. I was hoping somebody there did have the MATLAB. Let me try to log out to the net and share the screen.
I do it on my calculator, but I can't run it same way.
Sir,
Yeah. Yeah.
you can make
Yeah.
somebody record the session for me, please.
It's being recorded.
Oh, all right. Up.
All right. So now we are going to enter this into MATLAB and multiply it by 10, 0, and then let's see what we get. Just take my word for it there. So I'm going to say x equal square bracket 2 plus 3i semicolon, and this is 3i, and then 3 plus I'm going to put 2.5 I, close the bracket. And then we're going to call the next one y is equal to square bracket 10 semicolon 0, close the bracket. And then to find the two values now, I'm going to say z, that argument, is equal to inv for inverse, or you can use -1. So inv, the inverse of x, times star y. So I1, I2 is going to be equal to negative 2.2795 minus 0.9217 I, and negative 1.6650 minus 0.892 I. That's what the MATLAB gives me. So it just, this is my X, this is my Y, and I say X, I can put to the minus 1 or inverse X times the vector 10, 0, and I will get it. I guess
Okay.
this laptop doesn't necessarily zoom on it, so trying to find it so we can just show you what we type on the screen. But for now, that is the answer that we get. And most people leave the answer there. But that don't mean anything to me as a human. What does the current I1 equal minus 2.2795 minus 0.9217 I RJ mean? Don't mean anything. And I2 equal whatever we have there. Doesn't mean anything to us, human. We have to put it in a language that we can understand. So how do we put this I1 and I2 in a language that we understand and can get some information from? That was a question.
Sir.
Put a polar.
You ready to?
Polar.
Sir.
Polar coordinates.
Yes.
So let's convert this to polar coordinates. So what
Sir.
will be the amplitude? How do we find the magnitude? So
Sir,
let me
what
just-
you have for I2 there, sir?
Yeah.
What you have for I2 there? Negative 1.6650 minus what?
0.892.
Eh?
0.892.
Okay.
All right. So now, the current is going to be in this form. I is equal to A sine omega t plus phi, which is the phase angle. How do we find A?
So you find the square of the values and then square root them.
So A is going to be equal to the square root of negative 2.2795 square plus negative 0.9217 squared. So now, what is that going to be equal to? 2.2795 squared plus 0.9217 squared. Square root of that. .46. That's what I get. How do I find phi?
Tan inverse imaginary over real.
Tan inverse. So I'm going to press tan inverse the minus 0.892 divided by minus 1.665 close bracket equal. And I get 28.17 degrees. But I'm not going to write down 28.17 degrees.
That wouldn't be for I2.
Oh, sorry. Go again. So tan inverse bracket 0.9217 divided by 2.2795 close bracket. I get 22 degrees, but I'm not going to write down 22 degrees. I get 22 degrees. Here's why I'm not going to write down the 22 degrees. These two things are negative. So, in which quadrant is both x and y negative? Here.
Here.
Huh? So, it's 22 degrees there. Now, a little thing that might have slipped you in maths class is that sine is only between, any angle is only between 180, negative 180 and positive 180 degrees. So you have to express it as an angle between negative 180 and positive 180 degrees. So remember now, the two things are in the negative quadrant. The two things are in the negative quadrant. So this over here is negative, over here is negative. And then now I have to express this as an angle between 180 and minus 180. So this angle, positive is this way, going anti-clockwise, negative is going clockwise. So if it's 22 degrees in this quadrant here, that's the angle that I get. What is it equal to? Starting from 360 and going back. What angle would that be? If it's 22 up here, what angle would it be around here? 180.
158.
158. So therefore, I1 is going to be equal to 2.46 sine omega is 1 t minus, and the last thing now is that we would write it as 2.46 sine in our 115 degrees don't mean anything. We have to convert it to radian. Or you convert the 158 degrees to radian. Yes, we know. I'm asking a whole for 9 question.
So since that pi is equal to 180 degrees, so you have to divide that number, I guess, by 180. I get it as a fraction of pi.
Yeah, that is correct. Is it still hearing me?
We're still hearing you, sir, but the camera needs to be readjusted.
Yeah, because it freezes. Okay. Yeah. So to convert that to degrees, camera. All right, so to convert that to degrees, we're going to divide 158 by 180. I will get the answer in radians. And when I did that, I get 0.88. So this is the answer for I1. So we do a similar thing for I2. But we're not going to go through the whole rigmarole. We're just going to say I2 is 1.66 squared plus 0.89 squared sine t minus
So what you had gotten 5 for, sir?
hello?
What you had gotten 5 for?
Remember now, phi, tan inverse negative 0.9217 divided by negative 2.2795. And that is equal to 22 degrees.
Okay. Hold it there. Some
But we said that we couldn't write it as 22 degrees because this is negative and this is negative. So these two numbers are negative. So we know what quadrant, both of them negative, it would be 22 degrees in this quadrant here. So we have to express that answer. Where I said is you have to express anything in between 180 and negative 180 and 180. So between negative 180 and 180, you have to convert that. First of all, the 22 degrees in this quadrant means negative 158 degrees. That's what we write it down as. So, but we don't write our answers in terms of degrees because this t is in radians. So therefore, we have to convert this to radians. I would say that we convert it to radians by dividing the 158 by 180. So convert divide by 180. So we're doing the next one. So
hold it there.
So we were saying that it is going to be negative 0.89. Sorry, tan inverse So 1.66 squared plus 0.89 squared, square root of that is 1.88.
Excuse me, sir.
Yes,
So you're sure that the 2.2, where is it?
2.2.
The 2.2795, isn't that supposed to be positive?
Let me check it back. If it's positive, we're not changing to. Yep, it's positive. Oh. Assume it is negative. We're not changing it because if we change this to positive, then we have to the 2.46 won't be affected, but this angle will be affected because this now would mean that the y value is negative and the x value is positive. So the x value is positive, y value could fall down here. So that would be 22 degrees in this quadrant. All right, for the purposes, since I'm being recorded, let me say that this is positive. This is positive. So I hear Mr. Freighter loaded in gun.
No, man, I'm good, man. I'm good. Now just watch.
So this will be positive. Well, let me check. Let's check in here. Minus 0.9217 divided by 2.2795. Right? So it would give me negative 22 degrees. It will be here. And then now, so this will be 22 degrees. Convert it to radians, divide by 180.
Get 0.122 repeating.
0.122. All right. All right, so for the next one, going to be sine t, and find the tan inverse of negative 0.89 divided by negative 0.166.
And all that divided by 180.
Yeah.
Wait, sir, don't you have to multiply by pi as well when you're going into radians? You multiply by pi and divide by 180.
Oh, shoot. Yeah, you have to multiply by pi. So this is going to be, sorry, the pi at the end. And this one here is going to be, work out that one there for me.
I got 0.492.
All right. Now remember what we said. this one is negative. This is negative. This is negative. So the two negatives means that it is in the third quadrant here. So the 28 degrees that I get over here, I get 28 degrees. I have to convert that first of all to an angle over this side, starting from 0 and going back here. So that would be 152, and then I have to convert that to pi, to radian.
So where the 22 degrees should be?
Run again?
Where the 22 degrees should be? Which side of the quadrant?
This is, look at this here now. This is
No,
the
see,
one.
because what the camera button?
It's not on here anymore. It's not on here anymore. We take off the 22 degrees, so we need it with the 28 degrees that we get for this one here now. So I'm just going back to explain before. So the 22 degrees is over here.
Okay.
This is negative. This value, negative 0.92 is the y value, it's negative. And this value is the x value. So it's over this quadrant here. So and you get negative 22 degrees on your when you work it out. So that is what we convert it to radians from here. But this one here now is negative, negative. So it's in this quadrant, and we get 28 degrees. That's what we get. So I have to convert it to an angle over this side. So that is negative 152 degrees. Negative 152 degrees in radians. So that is 0.844 pi. So that will be my I2. So this now means something to me. The maximum value of the current is going to be 188 degrees, and it is lagging 0.844. So we can have an idea at any time. We can plug in time t equal 1 second. We can plug in and work out what the current is going to be. T equal 2 seconds, t equal 3 seconds. When we get the value as a complex number, it doesn't mean anything. But when we get the value and write it down like this, then now this is something that we can get some information from. So although we convert it to the complex domain to do something, or the S domain, we have to convert it back to our domain to understand what is really going on. So we know.
So over the sir, over the other side, to your right. Tan inverse of what that?
0.89 over negative 0.89 over negative 0.16.
Sir, you know, so I'm getting 0.49 for that though.
Like we correct me very respectfully. So you know that I'm getting 0.49. No, that's all right. No rubbish on the board, you know. We don't know where you get that from. But it's all right. So when you do tan inverse of all right, we can check it again. Let me try see your face. All right, so yep. Plus 180. Or you get 0.49.
So all right, so from tan inverse
Oh, yeah, tan inverse.
of the 0.89 over 1.66, we get 0.49 from there. And then I take away that from 180, I get 179.51. And I just divide that by 180 and then times that by pi.
There you get. When you do that, you get 0.49.
No, sir. The tan inverse part, so I get 0.49 from there.
Oh, let me check on it. 0.89 divided by 1.66. What is it? You divide this by this, I get 0.54. The tan inverse of 0.54, I getting 28.1 degrees. So, I don't understand. What you did?
Well, once. Oh yeah, I got the same thing, so I was in radians.
Oh, okay, cool. All right.
Sir.
Mm-hmm.
You can hold it over that side of the board to see what sign did it change when what's supposed to be positive was negative.
This.
Oh, that's supposed to be positive.
Yeah. I written it down as negative, but the answer is positive.
See what I'm doing on that one. So that now swap the answer. That now change the answer, sir, from 2.46.
If what?
If you change it to positive, it now change the answer from 2.46.
No. Remember, so squaring when you square this one, it don't matter if it's negative or positive. It didn't change this, it changed the angle. Because now when you have negative 0.9217 over 2.795, the quadrant that it is in is going to change. So you're going to get 22 degrees over this side, in this side. And then that 22 degrees work out to the value that we have here. So that was the change.
Okay. So go back over to the other side here. Something what other side?
Okay.
Right beside the calculator there, right? Just beside the calculator. The calculator you have 2 plus 3i.
3.
And what that? 3i, what that?
3 plus 5 over 2i.
No man, below. That line below it. 2 plus 3i. 3i, what that?
No, so this is 2 plus 3i, this is 3i, this is from here, and then this is 3j, which is a 3i. Put them closer together.
What I have in front of 3?
This,
Yeah.
is semicolon. If you're writing, putting it in MATLAB, then you have to put it in semicolon.
Okay, so it's 3i semicolon 3i. That's supposed to be 3i again.
Yeah. Marker starting to go.
Plus 5 2.
Everybody on board?
Plus 5 2. Yeah.
Yeah?
Yeah, man, yeah, man.
Okay. All right, so the next thing, I want to talk about.
Sir,
Target vectors. Hello?
in all the years of practicing engineering,
Huh?
in all the years of practicing engineering, have you ever been on any project that this level of maths, what you're doing on the board, you have to put it in practice?
Well, the University of Orange, the brother who was supervising it, it's NASA did work with it now. The maths what we doing here, so maybe maths compared to what I used to
Yeah, but I always wonder some of the maths that we're getting and some of these calculations, what project or what job you might be doing that requires you as an engineer to draw for it and begin to, what do you apply it to?
All right, so here's how we're going to answer this question. Going back to the same thing. The brethren who used to supervise me used to work with NASA. You think you could have told me at university, say me would have been working with a brethren and having to do some of the calculations thing that would work at NASA? The little dry foot boy from Winard Road. Wouldn't know.
Oh.
It wasn't this maths here, but it was to do with control theory. Same whole for complex number and blah 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 and this and that and you have to, and when I'm talking to you, you're not saying it 2 times. And you're not saying it, why I mean I understand. Sometimes when I'm talking, you go home, go look up the maths and then go sit down and go work your way through it. So i.e., we don't know who you're gonna work for, what I don't know. I can't tell you, say, 9 chances out of 10, you will never see this again in your life if it's certain things you're going to do. But we don't know. So I have to teach you everything.
Oh, so better you have it that in an eventuality, if you happen to be somewhere that requires it, at least you can always go back to it
Mm-hmm.
True.
Like I said, never in a million years I did know say I was gonna work with. Although if asked me to work on something, favor me say, oh, so this is so when you fire the missile, he make sure say it land at the right spot. I'm look for me and him take away the problem. I'm gonna never see it again.
Uh,
So you don't know.
yeah.
So I can't tell you say, boy, you don't need to learn this, because you'll never need. I never know. I never know. I don't. 9 chances out of 10, you know you never need. But suppose you do. You understand?
Makes sense. It makes sense. It makes sense for real.
We come over the point. To teach some little youngsters CXC, man. I have never, ever, ever, ever woke up anywhere when we use cumulative frequency curve in my life. Never ever see anybody anywhere use it, do anything with it, know about anything with it at all. We can't say, well, you know, go buck it up in your life, so you suppose they work with CXC. The whole entire grading thing where CXC do the other day, you know, is because the people who dealing with it now understand how to use cumulative frequency. So they mess up the whole entire thing.
Now understand how to use that, sir?
Cumulative frequency.
Okay.
I have never used it in my life. I've never seen it used in my life. But we know so it's that they did have to use to work out the people in grade after them do whatever it is that they have to do. And it's because them the things that they was ever going to use it in their life, and now boom, situation arise. I remember saying the head of CXC used to work at UTech. Or the functional head of CXC. He said, boy, never pay attention in our class when they do cumulative research. You don't know. All right, so we want to talk about finding eigenvalues and eigenvectors. Now, so let me just do it by hand and then talk about how you do it in MATLAB. And explain to you why the answer that you get in MATLAB is different from the answer that I am going to get. Same as well. Oh, let me add to Freighter and Company. Couple years ago, somebody who will teach at UTEC, he get a scholarship to go to China. And they wanted to teach some courses in China, invite some people. So he said he know this lecturer. That lecturer would be me. Who he would invite. And so I tell him, Bridget, I ain't not flying go nowhere no. I don't fly, I can't jump, I can't fly, so I don't I have things to go. Sit up for the 12 hours. I said, lucky I have come. So I went. Same Wuhan where the virus broke out. And it is interesting, say China do them thing, them have the place where they study virus and bacteria, that is Wuhan, the place where they study business, that is Beijing, and them have them university clusters different parts of the country. So it's strange that the virus would have broke out there, where they study virus. But anyhow, that is another story for another time. The point that I was making now, that I want to make now, is that they were saying to me, said, boy, you know anybody at your university who know how to use MATLAB? Because we want that person to come and help us sort out anything. We don't offer them a scholarship. Why? The MATLAB thing they write in English. And they have difficulty understanding the English. So even in China, knowing some of these little things here, not necessarily knowing the complex calculation, but knowing how to manipulate MATLAB. It's a skill that is marketable, but it's just we don't know.
Okay.
So, and by the way, let me go back. The engineers there were studying viruses and bacteria. So everybody in that place, there was the university was a study virus and bacteria. You know, so there was a plan to release it forward. Anyhow. All right.
A dangerous set of people, them, sir.
Huh?
That's a dangerous set of people, them.
No more than the Americans. All right. How do we find eigenvalues? Anybody remember? Anybody remember? Talk to me now.
Check on the math tool book.
Yes, sir. You have to multiply by lambda. The matrices.
Sorry, correct, but say it again, please. I prefer to write it this way. To find eigenvalues, I'm going to solve the equation lambda I minus a, the modulus of that, is equal to 0. That is the equation that I have to solve. So lambda put in a is 2, 3, 0, 1. X, we call it xy, I'm going to use xy, is equal to, I'm going to use the first eigenvalue that we have there, that's 2 x, y. So that's going to give me 2x plus 3y . If you write here, let's see. Let me write it and see. No, can't see. So this is going to give me 2x plus 3y is equal to 2x when you multiply this out. So that's 2x plus 3y is equal to 2x. And 0, this is y equal 2y. So usually there's a redundant equation. I see the redundant equation here, y equal 2y. So there's only one possible answer for that. Carry this 2y over here, get y equals 0. And if you plug in the y equals 0, there's always one equation that don't make no sense and the only solution is either x equal 1 or whatever. Now, if we plug in y equals 0 here, we're going to get 2x plus 3 times 0, put it in everything is equal to 2x. So 2x equals 2x. Again, that means that any value of x we choose will work. The usual thing we choose is that let x be equal to 1. So my eigenvalue is xy, x equal 1, y equals 0. So that's the first eigenvalue. I'm going to repeat it now for the next. So again, we're going to solve a, x equal lambda x. X is the vector. Some people write x1, x2, but we can't bother. So it's a, which is 2, 3, 0, 1. X equal lambda, which is 1. X plus 2x plus 3y is equal to x. And y equal y. Now, this one here is different. It's a y equal y. So any value of y that we choose will work. So I'm going to choose y equal 1 because y must equal y. So any value I choose. Once I can work out the thing, so that you see like this one here, the only way I'm going to get a value for y to equal to y is if we y equals 0. But if we can, we avoid a non-zero answer. So we're going to choose y equal. But this says choose any value of y you want to work. So choosing y equal 1. So plug that in here, that's 2x plus 3 times y is equal to x. So therefore x would be equal to, carry this over here, carry that over there, minus 3. So our second eigen value is x is equal to minus 3, y equal 1. So this is the first one. Now, to get the eigenvalue, we just type in eig A. And to get the eigenvector, I don't know why, it says VD equal eig A. It's going to give us, so let me just type it in here and tell you what the values I get. I'm going to write down the values that I get. A equals square bracket 2 space 3, semicolon, 0, space 1, square bracket, enter, and I'm going to say EIGA, EIG bracket A, close bracket, and I get the same 2 and 1. And then I'm going to put now square bracket V, comma, D, close bracket, equal EIG A all right. So let me write up here. You finish writing off over here?
Yes, sir.
You write down the answers of it. I'll tell you. Now, I'm putting two of them side by side and tell you what is going on. By the way, they're still out there.
Yes, sir.
Yes,
All right.
sir.
So what is that, sir, of in bracket? V, comma, D?
Yeah, square bracket equal EIGA. So you give me 2, 1. But now, for the eigenvectors, I have xy is equal to 1, 0. And the next xy is equal to -3, 1. MATLAB gives me 1, 0 as the first answer. And then it gives me -0.9487 and 0.3162. So what is going on there? One corresponds and this one doesn't. So what is going on there? Well, let me tell you what is going on there. The people who write MATLAB, when you square this and square this and add it up, when you square the two of them and add them, and then take the square root, you're supposed to get 1. So what they have done is take these two answers that I have here, they take it, 3 squared is 9, plus 1 squared is 1, 9 plus 1 is 10, the square root of 10 is 3 point something, 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 something. And so they divide it so that the 3 divided by the square root of 10. And I get the same answer that they get. You can see. I get the same 0.9487. So this thing here, this answer that they get is called normalized. So after they get this answer, they take it and divide by the vector by its length. Produce. So this is a unit vector. If you find square this and add them and find the square root, you're going to get 1. So they give you the answer as normalized. We are right to know the eigenvector as is. Now,
Shift the camera around so let me see the rest of the board.
You hear?
I can't see the extreme right. Either shift the board or shift the camera to your right.
Extreme right?
Shift it to your left a little. I know the board I camera to your
Up here, sir. And back down here, sir.
You're right. Up this one. I wonder if I don't know if to move this thing.
There's no difference, just this.
Yeah, maybe I'll look a thing up on my on Zoom. I come up and I don't know if I move it. I'll move this, you know.
You have to move the chat, the thing with all of the students' name.
That not try to move. All right, it moved.
You're good, sir.
Yeah?
It's
Put it
okay
back.
now, sir.
Okay. So when you work it out on MATLAB, you're going to get a different answer, but the answer is just basically what this is saying. If you take 3, 1, and then what they do is just give a vector. So the length is the same direction, but the length of the vector is such that it is 1. So these two are parallel to each other, but just that this one has a length 1, while this one has a length 10. But it's the same thing. So your eigenvalues and your eigenvectors are important. So now I'm going to go take it one step further.
So what is that? Find one A prime 0.
A to the 10.
Oh, A to the 10, okay.
And E to the 80 using the similarity transform. So here what? I'm just going to type in to find the eigenvalues. So I'm just going to type in and find the eigenvalues. Although I know what they are, because it's me right the problem. But let me just put them in MATLAB. I'll tell you something that the math teacher probably tell you in the MATLAB. So 6, 4, 0, 1. Close bracket there. Close bracket. And the eigenvalues, EIGA, turn out to be 6 and 1. Okay. Now, and the eigenvectors, I'm going to use V, D equal EIGA and see what are the vectors that they give me. 1 and 0.
Shift the board over, sir.
When I plug it in, I get 1 and 0. I'll go find them because we can use those numbers them to mix up. So A x equal lambda x 6, 4, 0, 1 xy plus 4y equals 6x. So 4y equals 0. So y equals 0. And if you plug in y equals 0 inside there, you don't have to go to the next one because next one says y equals 6y. So you know that y equals 0. So 6x equals 6x. When you plug in y equals 0, 6x equals 6x, you get let x equal 1. So the first eigenvalue is x equal 1. Y equals 0. The next one now is
1.
4, 0, 1 xy is equal to 1. So that is going to give me 6x plus 4 y is equal to x and y equal y. So so that implies that y equals 1. And when y equals 1, so you get 5x equal negative 4. So we're going to get x equal negative 4 over 5. So xy is 0.81. Now, to find any function of the similarity transform says that to find any function of A, the you're going to form this matrix. It's going to be P, D, P inverse. So now, let us talk about the diagonal. Well, first of all, let's talk about P. P is easy. P are the two eigenvectors. So the one eigenvector is 1, 0, and the next eigenvector is 0.81. P inverse now would be the inverse of that. So we're using MATLAB to find the inverse. So we're going to type in P equal one, square bracket first, 1, 0.8, semicolon, 0, 1, close the bracket. Now we're going to find inverse, INV, P. I found the eigenvalues, the eigenvectors, because the one that MATLAB gives me kind of messy. So this is 1, 0. Okay. Negative 0.8, 1. Now, D. What is D? What D is going to be the diagonal with the two eigenvectors. But if you remember, we were to find A to the 10. So the diagonal that we're going to have is 6 to the 10, 1 to the 10, and just fill up the other spaces in 0. So now what we are saying is that A to the 10 is going to be equal to P, which is 1, 0.801, D, which is 6 to the 10, 0, 0, 1 to the 10, P inverse, 1, negative 0.8, 0, 1. Not very helpful because MATLAB could have just raised the thing to the power 10, no problem. But in engineering, we are interested in something like e to the at, raising the vector, raising the matrix to a power. So you see P 1, 0.801. And then whatever the eigenvalue is going to replace the A. So E and the eigenvalue is 6, so it's e to the 16, 0, 0. And the next eigenvalue is 1, so we're going to put a 1, e to the t. 1, negative 0.8, 0, 1. And then we can multiply it out as we have our mind to work it out. All right, so let me multiply out this one. That's e to the 60 plus 0, that's still e to the 60. 0.8 e to the t. This is 0 e to the t. So multiply again, e to the 6t plus 0, 0, 0. Minus 0.8 e to the 6t plus 0.8 e to the t so this is what my e to the at would look like. So we can find any function of the matrix using this formula, which is called a similarity transform. So let me look this over here. F of A equals P D P inverse. It's called a similarity transform. So the diagonal matrix will always have the form using the eigenvalues of the matrix that we want to find, the function of. So e to the at is going to have e to the 6t, e to the t, because one eigenvalue is 1, 6, and the other eigenvalue is 1. So replace whatever the function is with the diagonal matrix. 2 zeros and the diagonal. The diagonal here is going to be made up of the matrix, the function that you want to find. So that is our similarity transform. Any questions, gentlemen? And ladies? Sorry.
Sir, where the man they get their matter from? Sir?
Where?
Yeah, where they get the maths from? Because
The surprising thing is that the annoying fact for you is that all of these problems, that most of the things that you see that people study in math is engineering, they come from, they arise from an engineering problem that an engineering person have to solve. So when them solve it, they come and say, all right, I have to teach them how to solve this problem. But I'm teaching it in abstract now, which is annoying, but all of them come from an engineering problem. Every single one of them. So next week we're going to look at some of the engineering problems that they come from.
sir, I got them a mash down.
The lecture?
Eh?
The next, I know, Tuesday. Tuesday evening is election.
Tuesday election?
So what kind of election I keep? Election not gone already?
No, US one, man. No,
Sir, we don't live in US.
Huh?
We don't live in US.
No, we think that someone might have to go.
Oh.
Summer business that, sir.
No, okay. Like me not interested. Whosoever will, may win. But all of my friends who migrate Ghana for them, I'm very interested. All right. We're going to stop it there. So next week, we're going to look at some problems and concern ourselves with the using some of these things to solve some of these problems. All right? And next week, we'll give you a second problem here.
Okay, sir.
What the S stand for side A? F stand for side A.
Where is the operator?
F side A, what it stand for?
The next assignment is to?
No, the F, that is the side A. What it stands for?
SIA.
The F. The side A bracket. Right, same like the auxiliary transform.
This?
No, F. Go to your left. Go to your left. Right, this is what F stand for.
F is a function. F bracket A. All right, so now so next week we're going to be talking about, and we need to come with the MATLAB next week here. Maybe my computer will not be crashed at that time. Maybe we can recover something.
So you know, when me not understand how you say A to the 10 and then all of is like tangent gone off. What next week, sir?
No, so we can just clear up that this is one problem and this is the next one. Remember, there's two problems I'd ask you now. Find A to the 10 and E to the 80.
Mm-hmm.
So A to the 10 is P. The diagonal matrix made up of whatever the eigenvalue is raised to the 10. So 6 to the 10, 1 to the 10. And then this is P inverse.
Oh, okay, sir.
And then E to the 80 now is P, same P, and same P inverse. But now the diagonal matrix is made up of the function again. And we replace A, notice in both cases, we replace A by the eigenvalue. So 6 in the first one and 1 in the second one.
Okay, sir. Gotcha. Gotcha.
All right. So next week, we continue looking at some problems with these.
Okay, sir. All right, sir. Have a good night.
All right.